Women in Data Science Worldwide has been around since 2015. We started pretty small as just one conference on Stanford campus, and our aim then was to simply feature outstanding women doing outstanding work in data science. And then we grew. We grew into a global movement, connecting women and also men around the world.
WIDS has grown organically, responding to what the needs of the community are, what women data scientists need, and exploring new ways to interact. Stanford University is proud to have been the birthplace of WIDS and a decade of growth. With our unique strength in data science, computation, and AI, Stanford was the ideal incubator to support this force for advancing diversity in data science. WIDS has had a lasting impact on data science at Stanford, with a co-founder of WIDS as a founding member of Stanford Data Science. Including multiple perspectives is baked into the core identity of our programs.
It's critical, and we need women in these roles. Every individual brings their own perspective, and so we need to make sure the entire workforce is represented.
Because it really fosters that sort of community building you want when it comes to not just data science, but really any, I think, efforts to try and engage more girls and women.
So the fairness mission that we have is really try to enable that two people with equal talent should have an equal shot at opportunities.
I also just encourage people not to give up and keep arguing for what you believe in and what's important to you and what you think will make a difference.
WIDS is about the sense of urgency we should all feel to ensure that women earn that seat at the table based on their skills and talent across the world.
WIDS has inspired me to believe that more is always possible.
WIDS has inspired me to think big. WIDS has inspired me to learn more.
It brings together some of the leading scientists in the world.
The journey is just beginning. At WIDS, we're not just envisioning a more inclusive future in data science and AI, we're making it happen. From equipping students with critical skills to advancing career development, we're expanding access to education, mentorship, and empowering support for tangible impact. The next decade starts now, with action, with us. Join us in shaping the future. Volunteer, mentor, or donate today.
Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. So, inshallah, today with the workshop will be introducing the using of deep learning in computer vision and NLP. We will covering what is the deep learning is and the fundamental of a neural network, which is the seed of the deep learning, and how deep learning can be utilizing in computer vision and natural language processing. And we will give the latest innovation like a multimodal AI and some success stories related to the deep learning. So first of all, deep learning is considered as a branch of machine learning applications. The deep learning has been covering numbers of fields such as NLP and computer vision. It's based on using a multi-layer neural network to learn the hidden pattern inside the data set. The main key features of the revolutions of deep learning is the features extractions, the automatic features extractions. The model can learn some hidden and useful pattern with the manual regarding the standards or the statistics machine learning tools that they need to utilizing some feature engineering techniques before applying the machine learning. Also, the large scaling pattern recognition from different type of content like images, audio, and natural language. The high performance with the big data. Revolutions حصل في deep learning related to the enormous amount of data has been released all these years, which help neural network to learn and train better and get better performance. Also, the GPU-powered competitions has also enhanced the revolutions of deep learning. So this is why deep learning now powers everything from Google search to autonomous vehicles. طبعا السيدز أو البذرة الأساسية of deep learning is a neural network, the artificial neural network. The concept of artificial neural network is not new. It's very developed from 1918 and before. The main component is based on using some layers, and these layers has been connected with the weights. The main benefits of this weight that can hold the most important features or information of this data set that's been trained, used to train this neural network. Also, the activation function that's been used, like RLU, has been used for fast training, sigmoid for probabilistic, and TAN for concentrating data. The numbers of loss function has been present or published last year's, like cross entropy functions, and it be used for classification problems, and mean square error also has been used for recognition problems. Also, the appearance of numbers optimization technique like gradient descent techniques to updated the weight to help the neural network to learn better from the training data set. Also has been released a new, it is not new, it's from like 10 years, the past 10 years, Adams optimizers has been also developed to increase the training stability. So, and this is not just two optimization techniques. There is also a number of optimization techniques has been developed the past years. And we can see from the image that is there is number of architectures of neural networks has been released from the past years, from the perceptrons architecture until the deep learning architectures. Each of these architectures has been developed and applied in some researches and have achieved some accuracy. And this is the evolution of the deep learning. From the main concept idea has been released from 1940, and the success stories has been achieved around 2015, when the AlexNet has been applied for a huge number of data set, which calls ImageNet, and achieve a good accuracy. Then this is the revolution of deep learning has been released since 2015. After 2012, after this, the numbers of different type of architectures of deep learning has been developed and applied to numbers of applications. Then we have also from the deep learning, from the conventional neural network to the generative neural network to transformer mechanism, until we reach the large multimodal technique, LLM. The main difference between the machine learning and the deep learning, as we said before, that is in the process of the machine learning, in applying the machine learning algorithm, we need a process, or feature engineering process, before we applying the classification or the forecasting models. So this steps is very crucial to help the machine learning tools to get more accurate in their output. But in the context of the deep learning, this step is not necessary, because the architectures of the neural networks can extract the features automatically, and these features can from each layer will be improved or will be enhanced in each layers until the last layer. So the prediction or the output or the target of this deep learning can predict the output more accurate. So this user rate of deep learning has been recently achieved a state-of-the-art for the result of innovative standards of tasks and applications. As we said before, based on the huge number of data set and the development of the GPU. Now we will introduce the computer vision. The main application of the computer vision is not new. It's been 20 or 30 years ago. So the conventional neural network has been used, or the deep learning has been used in the computer vision since the text storage is being applied from the AlexNet and after. So the conventional neural network, the CNN, has been used for numbers of applications for computer vision to, as we said, to extract the more important features from the data set. Model like ResNet, EfficientNet, and GoogleNet, and etc. All these models has been trained using ImageNet dataset with more than millions of images and thousands of classes. Then the object detection models like EULA and SFT advanced RSN has been used to detecting the object of the image to answer like specific questions: what is inside this image and where is it located. Also has been used for segmentation, and we can see it in the examples in the next slide, like UNet, Mascara, CNN has been classify every pixel and been used heavily in medical image and satellite images, also in robotics. Generatives model such as GN and diffusion models has been used to generate text and images content. So the computer vision can cover numbers of applications like autonomous driving, visual captioning, and image generation, artistic image creation. So this is some examples of classification, as we said, from like Fiji 16's models has been used to classify billions of images into thousands of classes from the ImageNet dataset. And this is the structures of each CNN that been used numbers of layers. Each layers will be used as we said to extract some important features from the image. Like this first layer can extract the edges of the image. The second layer and extracting the corners or the shades of the image. So each layers or each conventional layers inside this CNN can capturing some important and useful information and patterns inside this image. Then we'll follow by some fully connected layer to extract images. Here also to classify the object inside the images with the number of classes, and also how to to find the parsing or the sense parsing inside this image. Also here we can see the application of deep learning for localization and deduction, how they can localizing the object in different objects inside the images, and how they make segmentations boundary in each object and classify it. Here also can be used for sense parsing. So since they can understanding the position, the navigation, and the path planning, and also control the execution inside this or the scenario of this image. It can helpful for autonomous driving system. So they can tracking and categorizing the behaviors and all the sense inside this image, like if this car driving in which way, or if it is a stop or not. Also, deep learning can be used for autonomous driving. Like here, there is a numbers of sensing that can capture number of data set. This data set should be applied in the deep learning to help them to getting better scenario for or the action of the car. So you can see that the number of amount of data should be maintained for autonomous vehicle. Also, this data can be capturing from the cameras. They can capture 2D or 3D images or video. Also can be capturing from the radars to detect the object, and from the light detection and ranging to map the surrounding with more precision. This will help the car to make the correct actions based on this data when we maintain our dealing with this huge number of data by using a deep learning algorithm. Image captioning, also we can see numbers of applications now using this type of techniques to help the application to capturing the information of the sense of this image by applying two tasks from the computer vision and natural language processing. So the computer vision will help to recognize and understanding the scenario presented in this image, and NLP can cover this semantic by trying to describing this image in a sentence. Also, these techniques will help, especially for disabled people, to help them understanding, especially the blind people, to understanding the surrounding or the environment around them. Also can help for Google image search techniques. So if you're typing any text, they can help you to find the image related to this text. Or can be also use it for explaining or generating relevant caption from the videos or CCTV camera. Also here we use it for image generation. Usually you use a GN model, which is standard for generative adversarial network. It's been presented from 2014. This idea get research with deep learning to generate more realistic data set. The main idea of this model is to have two type of component or two type of network, the generators and discriminators, where the generators able to generate a random or generating image from random data or noisy data, and discriminators it should be classified if this image is been fake it's been generated, or it is a real image. So every time that the generators try to generate more realistic images, so the discriminator will not be able to classify. So since when the discriminator is not able to classify if this image is real or fake, meaning that generators has successfully or has been accurately generated the image. Here also, deep learning has been used for artistic of deep application. It's been used like 2015. It has been introduced by Leon. It allows to generate image style like from numbers of artists like Van Gogh art images to apply to another content. Also has been used of millions of apps. You can see that there's numbers of apps have used these techniques to apply different themes or techniques from some specific images. Also, it's been used for generating a video and scenarios of some animations. Also, deep learning has been used in healthcare, and this is success stories really need to represented of using this type of machine learning tools in medical data, such as images or audio or statistical data. So the deep learning has enhanced diagnosis accuracy since being used for X-ray or MRI scanning classifications. They can able to detecting and localizing abnormality in each of the medical images from each different type of diseases. And they show more high very accuracy classifications. They can reduce the error. They can able to detect the condition of these diseases more accurate than a human. They help to efficient clinical workflow. They help healthcare can extremely optimize a clinical workflow by automating repetitive tasks. They also provide can enhance efficiency, reduce administrative boundary, and allocate resources more efficiently in hospital. Personalizing medicine, they able to personalize the treatment for each patient based on their historical data set or historical information from their images, from their lab, they call it from the test lab, تحاليل الطبية for each patient, and they can predict the specific treatment or therapies will be more efficient for this type or in these cases of these patients. Also has been used for accelerating drug discovery, can be also used for remote monitoring. Also been used for protein discovering, the structured protein discovery to help understanding the structure of a protein in much better than before. Also can be used for face recognitions, which it's been useful for CCTV camera and another applications for related to the security issues. So in 2015, researchers has been released a FaceNet model, which is a convolutional neural network to recognizing faces, and they achieve approximately 99% accuracy. Now we will move for natural language processing using a deep learning. There is number of application of natural language processing, covering embedding and here we cover embedding and the recurrent neural network applications in understanding the natural language processing and how the transformers been helpful for this type of application, and what is the innovations related to this natural language processing. So the embedding technique, they use numbers of models to help understanding the language better, like using word-to-vec model. The deep learning techniques or models such as LSTM or GRU has been using to understanding the sequential of the language, messaging using loop architectures. So the neural network have the loop architecture to feed the network with the time consequences or sequentials probability to help the deep learning to understanding the previous historical of this content. Also, the transformer models has a breakthrough modern of NLP. The transformer allow full sentence processing, attention-based understanding. The main mechanism they use it is the self-attention. So they try to capturing the most important information in the context, which can generate it or understanding the sentence more. And the more power models like BRT, T5, GPT, and Gemini models has been used for this type of application, and one of the main success application is the ChatGPT, which is helping modern AI assistants. So NLP application used deep learning, such as machine translations. We can see that is the performance of Google Translate has been enhanced from the past years. The accurate translation has been increased like 60% in 2017. From sentiment analysis, deep learning achieved more than 90% accuracy and classify the text sentiment. Also has been used for chatbot and virtual assistant. Deep learning has been applying using some GPT models or Gemini to perform as a human being our human performance on understanding or generating a text. They can able to perform reasoning, generate some summarizations, and write coding and understanding the speech and the image. Also, for speech recognition, deep learning can be used to speech recognition, and has been achieved with the less than 10% error in the performance. And has been used to a number of applications such as smartphones applications, Siri and Alexa, etc. Multimodal, for one of the best innovations of deep learning models is multimodal algorithms that has been applied for different type of content, such as images and text and audio. So this type of input can be applied and processed in the same time. For example, GPT-40 under 300 millisecond response time, real-time voice and vision. They can generate it video, they can generate it sounds. Gemini also trained from billion of multi-models token, and also RTX use 100 and more robot dataset to perform or generate an action or task. So this type of model can help the future of AI. So since the main concept of deep learning is to get so if you get it more data set, if you get number of structured and unstructured data set, this will help the deep learning to learn better and to perform better. So since you feed the deep learning with the numbers of data set with different type of structure, this will enhance their performance and get the result with more accurate and more efficient. So this is some of success stories that we've been seeing last years. Like Tesla has been using deep learning to deal with the various numbers of data set. As we mentioned before, they can be applied to it can be utilizing this data set to help to make correct actions. And the main benefit that can be from this type of application is to reduce the accident more than 30%, because each action, since you're dealing with a huge number of data set, and this data set and each action will be based on this data set, so will be more accurate and the decision will be more efficient. So and which help to reduce the accident from the cars. DeepMind is another application for deducting or predicting the protein structures. Last years, many researchers has tried to understanding the structure of the protein, and the main purpose of this application is to understanding the structures and the behavior of a protein, so they can develop the drugs and can understanding the reason of the diseases. The deep learning has been applied to build this structure of the protein more than 200 billion protein structures. They use AlphaFold programs. They able to predict in the 3D structure of this protein, which is building the block of the life, and find the chemical component, also the shape of protein for the protein task, crucial, as we said before, to find the reasons of some diseases. This accurate of the building of the structure of protein is more than 62% to 76% accurate than comparing to the human. So also deep learning, as we mentioned before, has been applied a lot for healthcare sections. or applications. It can be used for, as you said, for medical diagnosis, for some disease deductions. Also, it can be segmentation, the region of abnormality inside some image, medical image. They found that is the deduction of such disease, like an early cancer deductions, can be improved more than 20%, and the decision can be more faster. Also, there is some number of recent papers has been published applying some deep learning techniques and some medical image to show the main benefit of using this type of techniques, like use it in brain tumor detection. They found that deep learning can 99% accurate than the others statistical machine learning. Also can be used for cancer staging using the CT image record and the records of the patients. They found the accuracy of using VG19, which is one type of transfer learning techniques, using 98% accurate. Also for chest X-ray for deduction some abnormality of the chest X-ray, the accurate was 94%. So this is some of the research paper has been published related to using deep learning techniques in a image data set. So this is the last slide. So thank you for listening. I'm not sure if